No, I mean the control is dependent on the voltage. So this is the reason. But what you mentioned is also important part in the control of the converter. I mean, because when they go to the unbalanced situation, with most of the situation is like this one, it is in compulsory behalf. Otherwise, some problem will happen. Okay, I was in a conference. I had a presentation about the three-phase system, and there was a very old, nice gentleman, and then he said that I have a question. And he was very angry with me and said that, you know, so if you don't consider the neutral point, then what happens if fault happening, if unbalance happening, if this type of thing? And then after lots of explanation, I say just one sentence, this is for the balance system, just like this one. And then he started the presentation. And he left all the people and just look at me all the time. If you don't consider this problem happen, if you don't consider that problem happen. I said, okay, thank you very much. And during the conference, when I was in the, for example, coffee room, and he just said, like this one. He was very angry with me. I said, okay, please, I made a mistake. Okay, but he was a very famous person also. And this is why I said that, you know, what you are mentioning is completely correct. And then the other point is that one engineer should be stupid if he doesn't consider this neutral point or grounding or this type of things. But when we are talking about the design, it's a different story. Yeah. Yeah, assuming that we consider that one. This type of thing is. Okay, any question? Was it clear for you?
Sir?
Yes.
PLL can track theta in every situation?
PLL?
PLL can track theta in every situation?
PLL basically is very sensitive to the disturbances. So this is the weakness of the PLL. And normally there are some other methods that you can use. But probably I can explain what is the mathematical equation behind of this. You want me to?
Minimum voltage magnitude requirement for that?
I mean, basically it should be, the amplitude should be equal with the reference voltage. But you can consider per unit value also. And if something happening, it makes a problem for that. And if the system is polluted by the harmonic or unbalance issue, it even makes much more worse. Okay, so, and the idea is that when we go inside the PLL, Arya?
Yes.
Do you know what is PLL?
Phase lock loop.
Okay, can you explain with the
Shall I come here?
no, calculation?
Calculation?
Yeah.
Like what? Like firstly.
Yeah, how we reach that one?
Pardon?
From voltage to.
You want the equation, sir?
Yeah. I have 1,000 euro, then I'm going to give to you. Yeah.
Depending on the load, the feedback
No,
is
you should think by yourself, not listening to the wrong person. Okay. So, so this is the phase, okay? VA, VB, VC. So basically, we have a clock which we provide the alpha, V beta. Okay, you probably know, but we get back to this one later. So if you don't know what is the Clark transformation, just don't worry. So we transfer from three-phase to two-phase. So it is basically VA, VB, DC, okay? And it transfer to V alpha, V beta. And then the reference is changing based on the V alpha and V beta. So PLL give this one, data. Okay, theta is equal to tangent inverse with beta to be alpha. Okay, so anything changing, the value of alpha beta changing, the theta changing, and the controller will be subjected to this change. So this makes a problem, and honestly, what the controller of, and then for this reason, the interface converter also gets some turbulence. Okay, so this is why the weakness of the PLL is that any disturbance happening, it gets in the problem situation. You got it?
It requires minimum voltage level.
Minimum voltage level.
Or threshold. If it requires threshold,
No,
how
I
we
mean-
can set this threshold?
Yeah, actually, the question is a little bit tricky because if you have the minimum voltage, it means that you don't have a stable voltage. So when you don't have a stable voltage, then PLL cannot be useful method for that one because it provides instead of providing actually the angle like this one, it provides like this one.
In distribution level, 0.6 or 0.7 kilovolt can be also stable.
0.6 and 0.
In distribution level,
Mm-hmm.
not transmission level.
So what is this? Read it again.
In distribution side,
Mm-hmm.
0.6 kilo or 0.7 kilovolt is also stable.
Stable. So you're talking about the SCR, short circuit ratio? Yeah, correct. I mean, what you're saying about the stability of the grid, okay? What you ask is different. I mean, if you're going to consider the impacts of the PLL and voltage on the PLL, then, but is there any standard to say that this 0.7 can be also considered the?
I was asking why you said if we convert VABC to VABQ, is there any requirement for minimum level of VABC?
I mean, we converted from ABC to DQ, okay,
Is there any
but
requirement?
yes, okay. When we talk about the requirement, it means that we cannot neglect the V0 also, homopolar, because then if we consider that it is something that we have a threshold for that one, it means that then the 0 point is not equal to 0, so you cannot neglect it. Then you should consider also the another wire for that. But if you say that there is something, I really don't know, it depends on the code of the country or how you, I have no idea about that. But I know that it doesn't work if you consider just VD and VQ. And I bet with you, if it works, I'll give that 1,000 euros to you. Okay? So, any questions so far? No?
And we are calling it microgrid.
Mm-hmm.
Why only micro? Can we call it picowatt? Is it something related to scale?
Microgrid. I mean, basically, this is a definition. This Robert Bob Lasser. This comes in Madison. He provides actually services this one. So, but I think the reason is that it's for the small scale, but and it makes sense also. I mean, you can call it non-grid, pico-grid, anything you can, but then it should be somehow, you should be too lucky if the people accept it or reject it. I mean, basically, this idea started from this Bob Lasser from University of Wisconsin, Madison. Bob Lasser. Yeah, I mean, at least he was one of the first that he started this topic. And then if you go with the Joseph Gorado, he probably have more than 1,000 applications just in one. this way.
Any volt like DC, you are making the and so is there any power voltage configuration
For microgrid, I mean, basically the concern of the microgrid is not the power or voltage. The main idea is that how we can, or the main contribution is that how we can provide electricity for a region that we have no access to distribution. So it's like working as an island mode. So this is the, and then it depended what kind of load do you have, if it is big load or small load. Even for the big load in the remote place, it doesn't make sense. If you have, I don't know, 10 megawatt power, then you make the 100-kilometer transmission line and go there. It's very expensive. So the idea is that we use this technology to provide the electricity for a point that we have no access to the distribution line. Yeah. I mean, it's a little bit tricky, but one of the most small one is a laptop. It was like 5 ampere for the loads, less than 1 kilowatt. I did in my lab. So this is my answer. I actually saw. Did you get it?
No, I was not actually, we were discussing.
Why you are talking?
Sir, actually,
The question.
yes, actually we had a doubt.
You are explaining to him.
No, he was telling me.
Okay.
Actually, we were discussing a point.
What point?
Sir, it was point out if there is a DC main supply, if any country is using the DC supply, then it would be the microgrid. Now there is no
I
need
mean,
of
microgrid can be DC, can be pure DC, can
No,
be
but
AC.
what he's saying that if any country is using DC, is there any country which is using DC as primarily, so that there is no thing of microgrid, like it will be considered directly as a microgrid, right?
there would be no use of
Then
inverter.
there is no need of inverter, this transmission lines as well.
I mean, I didn't say this thing, but this DC, there are some actually DC distribution line with 48 volts, something like this, which can provide electricity for the DC loads. But then it is somehow high demanding, and they said that nowadays Edison model is much more feasible in comparison with the Tesla model.
We were speaking about as it is the distributed generation, na?
What we are talking is that can it be used individually for house?
Yes,
DC,
yes,
fully.
yes. But depends that if you have AC or not. But my answer to you is like this one. If you listen at the beginning of this story, he said that we didn't like the Edison model because we didn't have power converters. So now assuming that in your home you have also AC, but DC model is better and can be as a source for the AC, but because we have the converter, we can convert it to AC and use it. Yeah.
So according to our preference, we can.
Yeah, it can be, and it's something that still they don't know that it is better that we shift from AC to DC or not, because lots of loads are nowadays DC, and then transferring even for the transmission line is much more better to go by DC. So yeah, HVDC system, and basically if transmission line is more than 80 kilometers or 50 miles, it makes sense go by DC instead of AC. So it means that you convert from AC to DC and then go by DC and then DC to AC. And do you know why 80 kilometers, more than 80 kilometers?
Power loss.
Resistance.
Cost. Cost. Yeah. Yeah. Sorry, I didn't hear you. Yeah. Yeah, cost is important. Yeah. Basically, when we are going to use the HVDC system, then we need the rectifier and converter. As you mentioned, we should pay for this conversion system. So assuming we have an AC and DC. So we use AC, but it have the induction losses. Okay, because Z is in cable is Z is R plus JL omega. So we have this voltage drop and losses also. But when we increase more than 80 kilometers, the power which can be saved, the price of the power, is more than the price of the converter. So for this, if you have a long, more than 80, so it economically makes sense we use actually, we buy the inverter and convert it to the DC and then transfer it to AC at the end. So this is the main reason that HVDC is more feasible when we have actually, we are going to go more than 100 kilometers on. But basically when we are talking about HVDC, normally something like 500 kilometers is very small scale. Sometimes reach to 3,000 kilometers, something like this. So we reach from distributed generation to HVDC. Now my question is that, is it DG or microgrid? DG. Why?
Because like we are considering both. So it, like actually we are considering this as well. So that's why we cannot consider it as a microgrid.
Sir, microgrid is that we can connect or disconnect. But here we can't disconnect. If we disconnect, it would not work.
Yes. So if we disconnect the grid, it cannot continue. Why? Because it cannot provide the voltage reference for the converter, and converter work like a current source, not voltage source. So, any question so far? No? Is it clear or complicated or clear? Okay.
Sir, suppose you are going to use inverter like home UPS inverter is there. Home UPS inverter is there.
Yeah.
That is there, we are going to enter to the reverse reference.
I mean, when you talk about the home, it depends on what kind of technology you use and where is your home. Your home is here or your home is remote place. If you go for home in remote place, then the converter should work like a grid form. Yeah.
Suppose you are going to use the generated renewable energy source that is only used to our home beside thing.
Yeah.
We can consider it as like this.
Yes, definitely. Yeah. Yeah. Because you have actually connect to grid
We can
also.
operate it in the isolated.
Yeah. Yeah, exactly. Because you have the measurement. Yeah, you have measurement for the grid also. Because when you go to isolated mode, still you have access to because otherwise when you return back to the grid connected mode, you cannot be synchronized with the grid. So you always need to be actually you have the measurement from the
Because
grid.
the rural area, the station is there.
No.
They are going to use only solar or wind.
Yeah.
That is only using for that equipment what we have constructed.
Yeah.
We can consider it as microgrid also.
I mean, you can consider if your model is working like a grid for, like a voltage source, grid forming. If it goes for grid forming, no, it is DG. Yeah. Well, you cannot actually supply your.
There is no possibility of connectivity.
Yeah. So it is not grid.
There is no breathing is there. Only that the renewable energy source is utilized for all the weather station is there, whatever it will be. I'm using that energy generated. As well as that is stored in the battery, and utilize the complete energy to that weather station whatever it is not connected to the grid.
Yes.
We can carry in the system as a microgrid.
Yes. So let me answer to your question by a question. Can you supply your load by this PV or not? You can. Okay, it's fine. Because you know, if you, I mean, it's come back to the control aspect. If your controller is designed in a way that your converter can act as a voltage source, it means that it doesn't need to be connected to the grid and provide the energy for the load. It is microgrid. Okay. So, any question? No? Yeah.
Here question.
A question?
Sir, for many of the industries or for the from the dam where the conversion occurs and we create the energy, these are transmitted hundred of kilometers or more than that. Then they are transmitted by DC supply or AC, or is there any conversion system between or the transmitter in between? They can supply for the longer range.
Yeah, they have this multi-terminal HVDC system. So it means that you can create 3,000 lines, 3,000 kilometer lines, but you can be connected or disconnected in the middle. So
No, but like how is it maintained for such long? As we said, it is 100 kilometers or more than that.
so how to maintain it?
So like, do we use any converters or something in between in the grid line?
I said that, yeah, if you consider this one as a multi-terminal, yes. Because for example, sorry? Yeah, I mean DC to DC is one, modular converter is one, and then yeah, yeah. Yeah, I mean, it depends, but if I'm going to just simply say that, you are going to, for example, connect the HVDC system to load between the beginning and end. So then, dependent that, it's a AC system, DC system. So you don't need to have a DC system and then DC-DC and then DC-AC. So you can provide actually this type of different technology that convert DC to AC. But what you said is that from here to here is 1,000 kilometers, okay? So we have a rectifier here, change the AC to DC, and we come here, we have a DC to AC converter. Up to here is clear. So in, for example, middle, there is a village that they need the electricity. Or there is some power plant that can provide the electricity. So then we have also this type of conversion system that change it and then provide the electricity or inject. So this is called multi-terminal HVDC system. So it means that in middle you can also provide that. Yeah. If you look at that one, why are they not microgrid? Because they cannot operate isolated from the grid. Yeah. Yes.
In grid farming technology case, this is not.
Grid farming or grid connected? Don't know. Do you know what is the difference between grid farming and grid following and grid connected? I'm assuming you feel that they are the same, yeah? You think that they are the same, yeah? No, they are not the same. Do you know what is the answer? Please see tomorrow. Okay? So, Arya, do you want me to stay after class actually answer to your questions? Yeah, then we can go see your hobby. Yeah. Okay, ask final question.
So actually the question was that, like, as you said that if it's disconnected from the main transmission line, if the appliances or anything won't work inside the home. But like in our case, like considering
Light goes off.
like electricity is off or it is turned off by the main station, but still some of the appliances will be working.
Oh,
Like
Inverter.
I said that if your controller is in a way that your inverter work as a voltage source, it is possible. But this one is not voltage source, it's current source. Because
But we can store in the batteries and that we can use.
yeah, battery is like a voltage source. Battery have a constant output voltage.
If we connect the battery inside this, then it can be the microgrid.
If you have a DC, only DC.
No. We can store the energy of solar.
No. No, the problem is that you cannot create the reference voltage in output of your converter, independent from the grid. This is the reason. didn't get it, yeah? Because you are not listening to me. You listen to this man and then you actually make the confusion for him and for yourself. Okay, so I tell you one time for the rest of your life. Okay, it's depend to you are trying to get it or not. If you are going to have a converter to provide electricity for load, you need to meet two criteria. So first, control the current. Second, the control of the voltage of the converter. Okay? But when you have a connection to the grid, you don't need to control the voltage of the converter. Why? Because you have the reference from the grid. Okay? So in this case, when grid is shut down, it means that you miss the reference. So your reference will be zero value. So it means that the output voltage of converter is zero. Doesn't matter you have lots of sources. Your converter is like a zero value actually. The output voltage is like a diode converter. Okay, so it doesn't work. So this is why if you are going to work in a independent from the grid, you need another level of the control, which say that second control level, which control the output voltage of the converter. So it creates the reference for the output voltage, and this converter now working like a voltage source. So in voltage source, you have a voltage, and this is a constant voltage that can provide electricity I for the load. Okay? But in this case, it is not like this. Okay? If I was the examiner for this course, I ask this one. And if I get a little bit if or else, I easily give the 0 to Ari. Because he was the main problem maker in the class. Yeah. Okay. Is it clear?
Yes.
Yes. PV or current source. Okay, yeah. No, it's actually when we have the wind turbine, again, the matter is not the source, the matter is the interfacing system that is controlling grid following mode or grid connected mode or grid for mode. Yeah, you will see this one. So, except this guy, does anybody have any question? No? Okay. So it means that you got it, okay? Should I ask a question? Some of you guys come here and explain it. So, no.
Cost.
Okay, anyway. I hope you get it, but later if you don't, just ask me again. So this is not microgrid, this is distributed generation system, because if we actually disconnect this one, it cannot support the loading isolated mode, like a islanding mode. So now we have the distributed generation, then microgrid, now smart grid. So now I would like to know that is there anyone can say that I never heard about the smart grid? Okay. Then is there anyone to say that I know what is the smart grid? No. So only Somi knows what is the smart grid. Yeah? You guys really don't know what is the smart grid? You know it? So why you don't hear it? Do you know what is a smart grid? Yeah. What was your name?
Siddhant.
Sit down.
Yes.
Sit down.
Yes.
Am I pronouncing it right? Sit down.
Yes, sir.
Siddhant.
Down.
T. It's T in ending.
Sit down.
Siddhant. Yes.
Sit down.
Yes, yes, yes.
Okay. Sit down. Do you know what is the smart grid?
Sir, actually during our practical, I had heard this concept by our faculty. But right now,
He's trying to pass this. If I'm wrong, this is the. Okay. Sit down. Yeah. Tell me what he said or she said.
that was 1 year back concept.
You forget. Okay. I'm confused.
Yes.
Arya, you don't.
I don't know.
Okay. Thank God. Yeah, I was explaining actually. Tomorrow again get back to explain and okay. So tell me what is the sit down.
Actually, in the microgrid, we have distribution generation as well as the load is there. The load demand as well as the distribution generation. Here by using the measuring technique, metering or measuring, and here we get the information from those sources, from the generation side as well as distribution side, where it is required, where to produce. So all information is controlled by a centralized control or distributed control line.
Okay. Great.
Like I said,
What?
it's able to predict the load and after load, and we able to reliably supply the generator.
Yeah.
That predictability.
Okay. So
Network that communicates with the power outages, with the supply.
yeah. Any other? Yes. Okay. Can be. Yeah.
It has some intelligence too. It is having communication between the generation as well as load. In between the generation.
Okay.
It can provide some intelligence to the grid.
Intelligence, what degree? What kind of intelligence? So, I mean, your answer is like that. What is the smart grid? The smart grid is the type of grid which is not stupid. Okay? Okay. So, tell me. You have enjoyed something. Yeah. Exactly what I actually here. A smart grid is a type of grid which can communicate between the generation and consumption. Okay, so it means that in a conventional grid, we said that always one of the weakness of the power grid was that generation must be more than consumption. Otherwise, the problem or outage will happen. But in a smart grid, we communicate between generation and consumption. So it means that we have this possibility. If generation is not enough for the consumption, we will optimize the consumption. So assuming that, for example, you are going to use the dishwasher. So you put this dirty dish in dishwasher and close and push the button, but it doesn't work. Why? Because the load center knows that now is 8 p.m. and the consumption is high. So you turn it on, but it doesn't work. Why? Because then they transfer this load to 11 p.m. when the actually load is not high, consumption is not high. So it can communicate. So we have different level of the control. So control of the component, control of the system, and control of whole network. So, for example, you can control the operation of your fridge, your dishwasher, your clothes washer. You can program it, and program is coming from the one central hub which communicates with the distribution grid. So this provides the information between the components, price, everything, frequency, voltage, everything related to the network, and then say that, okay, you turn it on, but please wait until the off peak. So it makes the balance between generation and consumption. So especially nowadays in this electric vehicle are so popular, and then you know, this like for example one car like in Nissan Leaf. Yeah, when you plug in, it takes 60 ampere. So do you know what is the 60 ampere? Yeah, we should put you in the middle and then get the barbecue. Okay? Yeah. So. Okay. Then, assuming that everybody has electric vehicle and they are coming to home 5 p.m., plug in, then it makes a big spike over the grid. So this is not something, it makes an instability for the grid. So for this, the charging station in your home will be a little bit more smart, it communicates with the network, and also provide some things for you, like awareness that if you are going to charge this one, you should pay 2 times. It is better by transfer discharging to, I don't know, 1 a.m. or 11 p.m., something that the stress over the grid is less. So it is much more better that, you know, you reduce. So this type of communication creates a smart grid. So in a smart grid, we have 3 main parts: grid, consumption, smart loads, and also local power generation. So conclusion, distributed generation technology can be part of the microgrid, and then microgrid can be part of the smart grid. So by this, we can actually provide the economical benefit from the customer point of view, and we can also increase the stability of the network that we are using the electricity from that. So, this is the general structure of the distributed generation technology and grid. So, if you look at this part, you see that we have the building, we have local power generation and consumption. So we shape actually something like this as a microgrid, but in all together they are part of the grid. And the idea is that we provide a balance between generation and consumption. Even the consumption is not less than the generation. So this is the difference between the smart grid and stupid grid or conventional grid. So now I'm going to provide assignment to you, and then looking for the best solution with 1,000 euros actually price. So now we are going to provide electricity for a community. Okay, so assuming that we have electric vehicle, we have storage devices, we have PV panel, we have then lots of stuff that you use for the daily life, and then now we are going to provide a smart community which provides benefit from the customer point of view and from the grid point of view. So what is the best solution for that one? So you have sometimes in peer group or tree, you can actually make something and present here. And then the winner will be very rich. Okay? So, take your time, talk together, and then design something that I see. Okay? Okay, look. You already lost the 1,000. But I say again. So assuming that you have a community, you live in, it can be university, for example. So then you have different types of the storage, then PV, electric vehicle station, and then this possibility to be connected to the grid and disconnected. But what is the best solution to provide a smart community? Yeah, you can present something and then later we see that, yeah. Okay, my advice to you is that before you find, actually you write something, try to share the idea together, think a little bit, then share the idea together, then provide the solution. This is not just something that you remember, okay, I can do this one, that one, okay. No. Just try to communicate in a teamwork and see that what will be the best solution for that. Okay? And I have something in my mind. Honestly, if you answer this one, I will be really happy to see that you notice this point. Okay. What? I don't know. Okay. I said that from customer point of view and from network point of view. So what is the best solution? Yeah, both points. So then we see that what kind of service you can provide for the grid and what kind of service you can get from the grid.
In one case, the community, it's a bigger community, and for the other is smaller community. For the bigger community, already we have an established network, established grid, right? And like suppose if I take an example, we have a bigger city and everyone has their own equipment, like purchased equipment. They cannot shift to a new technology or new equipments, right? So you have an existing grid, which is already an AC grid, right? So AC grid, in that case, you can connect distributed networks, right? Distributed generators, right? And those should be connected to the AC grid. That's what I find a solution. And the second solution for the smaller community is a DC grid where the community is very small and you have a chance to replace the equipment which works on DC. Basically, most of the applications runs on DC. So there we can generate, like we can provide DC supply itself through the grid, right? And even we have some grids over there which are DC grid itself, right? And it's easy to connect those grids because it's a small community and there is no burden, huge burden to replace the equipment, household or any different types of equipment. That's my solution for both.
Thank you. And what is the role of the, for example, storage devices and electric vehicle, this type of thing?
Then obviously in AC grid we need converters and those are already available for electrical vehicles. So those all stuff comes under AC grid. Even in DC, that's a solution. Only you have DC requirements and you have DC grid. Then storage is DC. Storage becomes storage. So for small communities, DC is better.
Yeah. So do you believe that, for example, one day we reach in the point that for example, in this university, we have this possibility to use the electric vehicle as a source of energy instead of the load. I mean,
DC.
Yeah.
Yeah, DC grid.
Yeah.
Like I'll give an example of my college, what I did, like what our college did. We installed PV cells, right? And we have generated 48 volts DC voltage for whole campus, for our whole campus. And even the SMPS of computer we developed ourselves in our R&D. The fans regulator, sorry, the BLD, we use BLDC motor for fans. It's around before the 2018 we have did this, 2015 to 18. We shifted our whole campus from AC grid to DC. Our campus.
Yeah.
So that's what we know the things like DC. If you supply DC, it's very better. Like changing SMPS of computer is very difficult task, but we did it that way.
It's excellent idea actually. It started first at Illinois Institute of Technology by this Shiley Mohammed. He actually made this idea in the campus, and they reaching the point that they isolated whole campus from the grid. Yeah. And one important aspect was that they provided the local charging station.
Yes, we have a charging station also,
Yeah.
which is connected to that
Yeah.
EV charging station.
Yeah, this is excellent idea. Okay, thank you. Yeah.
So when you start from a small institute, you can have, like you can make it bigger.
Yes. Yeah.
Like it is inspiration to all of us.
Yeah, but they spent $15 million for that one.
No, our is very less. We got around 20 lakhs for this from government, and we experimented.
Excellent idea. Thank you very much. Yeah. So, come in. Come in. It makes everything complicated.
Sir, from your question, here the grid is benefited as well as the consumer is also benefited. Okay, here PV is there.
Yes.
And here I am going to get forecasting, weather forecasting information. As well as here I have battery storage as well as EV. And also it is connected to the grid, to the bidirectional inverter, as well as the load is there. So here I am going to plan the information we have from the grid as well as battery as well as EV and weather forecasting. Here I am going to charge my electrical vehicles in the community when it is in off-peak time. So the cost is also very less compared to the peak time. At that time, I am going to charge it. So the burden, if suppose I am going to charge my EV vehicles at the peak time, it is burden on the grid. So here I am going to plan, I would like to charge my electrical vehicles in the community during the off-peak time. Okay, as well as here I have information about the weather forecasting. Also I need to plan according to that.
Okay.
So as well as I am going to plan my journey, because I would like to go from my home to office, or office to home. The energy storage required to me is very less.
Yes.
40% of the SOC is enough. That is, I am considering that is critical for me, for my EV vehicle. What is the extra energy stored in the EV vehicle? That is, I am going to supply it to the grid during the on-peak time. So here I am going to supply the energy to the grid. Here I can earn more. So that is benefit to the consumer.
But do you believe that it's better that you sell it to the grid or use for your own load?
Sir?
You have a storage, okay?
Yeah.
Can be vehicle or supply storage. Do you believe it is better you use it for your own consumption or for the selling to the grid? Which one is better?
For on consumption, I have a battery system is there. I am utilizing the energy stored in the battery for my home appliance purpose, and the extra energy stored in the EV vehicle, that is supplied to the grid. Because I was stored energy from the grid or PV during the off-grid time, the charges is less. Here I am going to supply to the grid when the charges is high.
So you believe that, by using the storage devices, we can get the maximum benefit. Doesn't matter, sometimes charge or sometimes discharge. Yeah?
Yes.
Without the storage, it is...
But here we have the weather forecasting information.
Yeah,
That is fed to the my controller.
Yeah.
It is going to operate with respect to all the information that is we get from the battery storage as well as the EV storage, the PV generation and the load demand during the time. All the information it is going to operate. Whether it is going to deliver to the grid or it is charges from the grid or charges from the PV, it is completely going to operated by the controller in the smart grid by using that entire information.
But what if, for example, because we have some constraint regarding the downgrade the actually operation of the storage devices in vehicle or the price of the storage devices or most of sometimes also the forecast is not correct. So this type of things cannot guarantee the 100% reliability. But basically, idea is using the storage is somehow very interesting. But now European Commission goes toward using the PV or more than the storage in this. I mean, they said that we can use storage. This is something which is important, but the PV is really the role of PV nowadays is highly attractive, and they are going to use PV everywhere. So just a simple example that nowadays they are going to integrate PV with the vehicle. They are going to integrate the PV with the charging station. They are going to integrate PV with the power grid, home, everywhere. Okay, and India is the place that you must do it. But anyway, thank you very much. Excellent idea. Thank you.
Actually, suppose we are going to use the PV, the peak time is around evening 6 to 10. At that time here we require more load to supply with more load.
Yeah.
So when we are charging in the daytime, we can utilize this to supply to the grid. We can reduce the burden on the grid at that time. At that time, the grid is benefited from these setup.
Yeah. And one concern is that when you are interacting with the grid, charging, discharging, this type of things has some losses. And when you buy and sell it, then it is not 100%. You cannot say that get the benefit. So you should be. One aspect is to use for your own consumption. They have the same meaning. Because even during the peak, if you sell it, you can only sell the extra power because you need for your own load also. But anyway, thank you very much. Yeah. So, any other idea? Arya?
We have an idea, sir.
You have an idea?
Yes, sir.
Good. You were out of the class, so
No.
you made it. Okay, come here. Tell me what is your idea. I'm eager to see your idea.
We will be considering the AC grids, that is the power station, for the daily up.
Okay.
Then we are considering the DG, that is the DG distribution source for the smart grid, and through the smart grid it will be passed on to the EV charging station.
What do you mean by a smart grid?
Smart grid is like it detects whatever the requirement according to the detected requirement. The output is given.
Okay.
So like considering the EV charging station, the load will be variable. It won't be constant. Like maybe at the evening time the load will be more, in the morning time or at the non-peak time it will be less. So depending on that the smart grid will decide, and the power will be passed on to the EV charging station. Then we have used the PVC panels as well, which will charge the battery, the power supply battery, the different battery. And this battery will be used for other stuffs as well as daily appliances. So if the daily appliances can be used using this battery, which we got the power from PVC panel, the PV panels, it will be used through the battery. And if the battery is drained out or something like that, or if it's sensed like that by the smart grid, then it will shift to the AC grids, that is the main power station, and daily appliances will work on that. So like we are trying to minimize the use of AC grids using the smart grid system, using the batteries, and for EV charging station as well, we are using the smart grid.
So it can detect for the peak time, more power can be drawn out.
How would you like to minimize this?
Like we are using various sources like that is wind energy, renewable sources of energy, wind energy, or using PV panels. And you showed the example of a smart PV panel. Like according to the direction of the sun, it will change the direction of its own to take the sun. So we are using that thing, like the PVC panels of that type.
Okay. Is excellent idea. Yeah, I like it.
But do you didn't you get it, or it's fine?
I mean, what I'm looking for is that you said that maximize or minimize something. Can you show me by equation?
Not by the equation,
Okay,
sorry.
good. So you were close to 1,000 euro, but now it's zero.
Okay, no issues, sir.
Okay, excellent. Thank you very much. Yeah. So any other different idea? No? Good. Okay, please. You're getting close to the answer and I get stressed.
Okay, so the first method, what we can do is, we can add the renewable part in the grid.
Yes.
And besides the renewable part, we can provide a support of the battery, so that we can define the average consumption that the conventional power supply gives. So let's say if the conventional power supply gives me around 100 megawatts on an average. So what we can do is we can use the battery, means it can switch between the batteries and the renewable source. So like we have defined that we got 100 megawatts of power supply from this part. And the remaining power supply we can use the conventional ones, because it's not, means in the current situation it's not feasible to completely go on renewable. So we can use the conventional as a support part for the power supply. And what we can do is we can request the users, means whichever users are going to use the power supply, we can ask them two things, that if it is feasible, we can ask them to store a battery for it, so that whenever the high demand time, they can switch on their own battery, and during the low demand time, they can use it from the grid. And one more part we can do is we can use the ask the user to use PVs, photovoltaics, means the solar part, and if they have extra power with them, means if they on an average if they use around 8 to 10 watts, we can ask them to supply the remaining power on the grid. And the means this way what can happen is it will look like they are using more power, but on the grid there will be less stress.
Can you show by equation to me?
Sir, means which equations exactly?
I don't know. What you mentioned, it should be implemented. And implementation is coming from the equations. Yeah.
Sir, means like, can I give just a rough part?
If you don't like, it's fine actually.
Okay.
Udaya, you want to pay or I should pay? Okay. Yeah. No, 1,000. I told 1,000, didn't say 1,000 euro, dollar, rupee. No, I'll pay 1,000 euro. Yeah. I should bring actually. So tomorrow we start from the equations, calculations, okay? So if you miss the session, then I think rest of the session are somehow linked to these sessions. So be careful to be on time. And if they make the delay, they really should buy something. Yeah. Tomorrow, chapter 4 will start. Yeah. Okay. You can start by a storage and then I go for that one. Okay. No, it's fine. The important is that we meet what we promised.
Okay, so what I basically did here is I've taken just 3 users. First user, let's say it's just the home appliances, a single house. In this part, it basically it is generating 10 kilowatts through photovoltaic, and what is happening is it is using 3 kilowatts. 3 kilowatts it is using. So what it can do is it can pass on the 3 kilowatt to the grid.
Okay.
And suppose I have the second user. Let's say it's a big company. It is using 5 kilowatts on an average, and it is generating 500 kilowatts, whereas it is using 1500 kilowatts on an average. So this will be taking around 10,000 kilowatts from the grid. Whereas the third user, it is straight away taking 2000 kilowatts. It is not generating anything. It is up to them. And what I can do is whatever it is generating, I can get the net value, the amount it is been used, the amount the grid must require. And this part we can get from the renewable part and the conventional part.
Yeah. It makes sense, but you should also shape it in a better way. So let me explain a little bit different. Thank you very much. Thank you. Yeah. You are going to come here. Yeah. It is the general model. Yeah. You said that we use the rectifier, charge the EV, and also we use the PV for DG. Yeah. Okay, thank you. Now this is the way we can do. Okay, but it's like a mathematical model for the integration. But now the question was that how we can maximize the benefit for the community. Okay, but it's good. Thank you. So, again, get back the question. What is how we can maximize the benefit? It's again this sugar and coffee. Why is like this one? Why is it like this one? And why? So it is not the complicated question. And the idea for asking this question is that you don't need to make everything complicated. Okay? So you should find the easiest solution. So we have loads, okay? So we have generation in community, okay? Then generation can be one from PV, all right? And from EV, yeah? Do we have something else? We have ESS. Yeah? What? Balance condition? Power balance condition. No, now we are talking about, okay, so but energy storage system. Yeah. Then what else we have? We have loads, yeah? Yeah, like minus PL, okay? And then this electric vehicle can be also considered as a load, okay? So P electric vehicle in this is all charging and this is charging. So what else do we have? Energy storage can be also.
EV in the charging it is like load.
Yeah, we put this one. Yeah, and ESS also can be in charging. So this charging, okay. Yeah. So then, what else we have? So we have different types, actually different. Just a simple example. So what is the idea? To reduce the stress over the grid, and this means that we have less dependency to the grid. Okay? So then, if we reach to zero value, so it means that our consumption is equal to our generation. Yeah, even the best is that the positive is the, like this one. Okay? So I don't care actually what is happening. But if we optimize this objective function, then we reach in the point that we have the best answer for the maximum profit. Okay? So what happens there? It means that it seems very simple, but then we should consider each one as an agent. This one, this one, this one, this one, this one, this one. Okay? So we don't know what happened when we reach in this objective function. What is happening when we are in charging or in the charging? And for the vehicle also the same. So you don't need to make something, okay, I do this one, that one, this one, that one, okay? So you should make it like a connection between generation and consumption, then optimize this one. And optimizing this one is not complicated things. Okay, you need some actually constraint and then run the program. So it's not that much complicated issue. So basically, I mean, we see that, later that we optimize the system, and you see that it provides a very routine way, but we get the maximum actually benefit. So it's a something that, nowadays we are working too much, but we make that one very complicated for ourselves. This is not something that, make too much energy for that one and then reach that. We have some potential here. So we have the electric vehicle, we have charging station, we have PV, we have actually smart guys that control the loads. Then we reach the zero value for the objective function. Then it provides a balanced system for community and also independent from the grid. So in fact, by this optimization, we minimize the stress over the grid when the load is high, and also we minimize the payment from the community perspective to pay the distribution grid. In addition, by the tuning well, we see later how we can tune it. We see that we have a more reliable energy for our community. So in fact, we can somehow provide the stable operating condition without paying something. So the idea for this question was that next days we have actually some mathematical equation again from the basic of the control of the converter go to I don't know where we reach. Okay. So thank you very much. Today is getting finished. Yeah, we see each other tomorrow.